Yeah, so this is just office hours, so you don't have anything prepared.
Okay, if it says like you have to write the code, because like some questions are just like write a code. You have to make a main too.
No.
So like if it's like asking you to
Yeah,
return,
you could just like if it says like write code that prints hi, you can just literally answer this, and that's fine.
but if you have a bunch of functions,
Then you call the function.
just like outside of the thing, just
Yeah, yeah.
like you still have to. So you still have to show how the functions would run. Like you have to call the function.
So if the question is like, for example, like write code that prints hi, and you like write a function like that, I think that's what you're asking. Then you would need to say like print hi like this.
Even if it just says write.
If it just says write the function, then yeah.
Yeah.
If the like parameter for the function is like an input, do you just like put that outside of the function? Like if I want it to be an input, like asking the user for something.
I mean, if it says that you should be asking the user for something, so like for example, if you're saying like, like ask the user for their name and return your name is and then name or something, right? So then it would be like, so like this or something. And then maybe you'd return like, something like this.
I ask how you did question 6 on the 2022 midterm. I'm looking at the solution, I just don't understand it.
Don't know them by name. 2022 question 6. Oh, okay. So that's also like recorded somewhere. But so we haven't quite done replace. So what replace does is, or maybe I think we mentioned it a little bit. So what replace does is it replaces kind of whatever is this with whatever is the new thing. And so does that make sense? It replaces like any occurrence of, for example, ZZZ with kind of whatever new thing. It doesn't have to be the same length either. It can be like this, right? And then str of kind of a number is just the string. And then the idea is we want to replace the dot just with nothing. And then it's like this. And then from this one, if this is the string, we want to get like asset1, asset2, asset3, and so on, right? So we have the kind of like, and initially it's going to be 0. And then we say S is kind of the string representation of pi, and then we just replace the dot with nothing. So that means that S is now like this. And then the first time we want to return S at 0, and then S at 1, S at 2, and so on. So I'll start with index being equal to -1, and then I'll increment it to 0, and I'll return S at index. And then the next time it's going to be S at 1, and then S at 2, and then S at 3. Does that make sense?
Yeah. So you don't need a loop in this one?
Well, no, because what the question is asking is if you repeatedly call the function. Right. So like you can call the function in the loop, but you're like saying like, get me the 3, get me the 1.
Okay. Thank you.
Yeah. Oh, Harry, shouldn't you be studying for like a midterm that you mentioned before? Well, yeah, I'm just like, I don't have anything prepared, right? So just waiting for questions. Yeah, apparently the only people on Discord are like not first years, which is kind of weird. Okay. Wait, Civ has no midterm? What? Okay, I'm gonna be entertaining myself in Discord if you don't have to ask questions. All right. All right. So this is what we have there, right? So we have this, so we have the energy function and we have the printer, and we have the parental energies. Runs. So what we want to do essentially is just, so first of all, kind of what's going on here. So if we have, say, that one open, that one's open, right? Yeah. So, so if we set those guys to this, then what we have is basically this function E for every possible input X. Like with me so far?
Yeah.
Okay. So all that the lab is asking is to adjust the W's in a particular way. So the way it asks you to adjust the W's is to say, x0, x0, x1, x2 is what is it? Do we see where the x's are? Okay, yeah, minus 1, 1, 1. All right. And then what we're saying is we want for E to decrease, which means that we want for the sum of those three terms to increase, which means that we want to say that if x0 times x1 is greater than 0, we want to increase W01 by a little bit. And otherwise, we want to decrease it by a little bit. And then similarly, we want to say if x1 times x2 is greater than 0, then we want to say W12 increases by a little bit, and otherwise it decreases by a little bit. And if x0, x2, 0, again, W02 increase by a little bit. otherwise decrease by a little bit. Not type anymore. And that's just because we want for term 1, term 2, plus term 2, plus term 3 to be as large as possible. And if x0 times x1 is positive, then we want for this entire thing to be a little bit more positive. If it's negative, then we want it to be a little bit more negative. So yeah, and then it asks you, like, if you do it the once, what is it going to look like? A little bit like this. And here we're saying make -1, 1, 1 a little bit more negative, and we did make it a little bit more negative, right? And then it's just saying, well, like, okay, like we made it a little bit negative, but not very negative. So like, what if we just repeat this several times, right? So we'll move this into a function. So we'll say, and we'll give it x1, x0, x1, x2, and we'll give it w01, w02, w12, and we'll say just repeat it each first time. Just this thing. All right. So, okay. So now I can just try it. So, well, say 5 times. And what you see is that, it became this. And then the last thing, by the way, this is also recorded on YouTube. So I'm going to do it like kind of quickly. So just kind of for the lab session for whatever, lab 6, I guess. So once we're done, what we want to do is we want to return the new W's, right? So what this does is that repeatedly adjusts the W's, but this function right now, it doesn't change the W's outside the function because those W's are local. So we'll just say return W01, W02, W12. So this just makes a list with 3 elements that are like this. So I'll say like result is this, and then to extract it with the tools that you have, it's just going to be like this. Right, so I get this list, and then I extract the weights from the list, and then I extract the results from the list. That's it. Sure. Yeah, so I don't have anything prepared. I'm just like answering questions. And
I got questions.
okay.
So, well, maybe.
Same, but for tomorrow.
Do you have any solutions for the 2020?
No, I don't have those, but chatgpt.com might work.
Sometime.
Good times.
I'm working my way up. Yeah. Is this the Hopfield question from the lab?
Mhm.
No, I did that one.
Yeah.
That one didn't.
I really my favorite term. Like it has like is that does it matter like what type of parameters that we have? Because here it says it's like a list and then a string. But then here it's like n.
List of strings and target string. Yeah, so that was a typo. Yeah.
Okay. So then we
Yeah,
are
it's
taking
supposed
a
to be
list
two.
of string.
Yeah,
Okay.
yeah.
Okay. And then we can use this in like this next because the next one is like kind of building.
Maybe. So most frequent.
Should return.
Yeah, I guess. Yeah, that makes sense. Yeah.
Okay.
Yeah, cold. Oh. Yeah, oh.
Yeah. Yeah.
Like go over, I think that's what summary of the said.
So exec just runs the code that you give. So for example, if the code is like A is equal to 5, B is equal to A times 15, then you can just want to run it. So if you run it, then, B is 15 times 5. So it's as if this were code that you ran. And then eval just evaluates an expression. So you can say eval 5 plus 12, and the value of that is 70. So the difference is exec runs the code that doesn't have a value. It just has the effect of having run the code. And then eval just takes an expression as if you were trying to say, what is the value of that? And it tells you what the value is.
If I had like a string plus a string, it wouldn't like there wouldn't be any.
Oh, I mean, a string plus a string also has a value, right? So like ABC plus DEF, that has a value. So you can say, if you wanted to, eval ABC plus DEF. So the only thing is like this has to be a string. So if the string contains quotes itself, you cannot have, if you remember, kind of single quotes inside single quotes or double quotes inside double quotes. So for that reason, I alternated, but that's the only reason, right? So the kind of the thing of it is like this is a string. It has to be inside some kind of quotation. Yeah. Oh, yeah.
And that string is just a string and then you insert the property.
Sure. So the F string is a way to substitute in values inside a string, right? So it could be like X, and then you would say like find it first, and then this is like this. Yeah. Sorry, go ahead. So not quite because so several ways to answer this question. So like if you say this is fine, but this is literally going to be like open parentheses close x close parentheses. So this is just going to be this, right? If what you meant is, well, like what if you say something like this? Yeah, you could do it. That would be 42. And then you can do something like this. This would also be 42. So if it's inside the curly braces, then it's something that's substituted in. And then the round parentheses are just a way of grouping operations, right? So they're not going to show up. On the other hand, if they're outside of the curly braces, they're a character like any other character. Yeah. Yeah.
Just for formatting, we'll have a page to work as kind of a blank space to hash out things. And if we run out of space, do we just use some of that blank space that's used as a rough draft space?
Yeah.
Thank you very much, Professor.
Yeah. Oh, yeah. So I think the simplest way to understand it is if you have a list like this. So one thing, and this is like the first thing that we saw, right? Is like if you say like what's L at length of L minus 1, then that's the last element because it goes like 0, 1, 2, 3, and then 3 is the length minus 1. And then in Python, you can also basically leave out length of L. So L at minus 1 is the same as L at length of L minus 1. And then you can also do minus 2, and that would be the second from the end. Yeah. Yeah, so I don't actually know. Apparently you can. Yeah. So I think what you're saying is that, yeah, good luck. So I think what you're saying is that it's not quite equivalent because this is just minus 1 and this would work. Yes, that is a good one. So this is just L at minus 1. So that, yeah, so in that way, it's not exactly equivalent. Yeah.
Okay, in case of slicing, can we use the negative number and the positive number at the same time?
Yeah.
For example, we start at -5 and start at 3. Or start at -5 and end at 3.
I think you're saying start at -5 and end at 8. So something like this. This seems quite exotic. I would not do it just because who knows what that's gonna do. And it's a little bit weird that this is like, yeah, so like something like this. So apparently you can do that, but I would not recommend that. I did not know how to predict what that would do. Yeah.
Steps.
So you mean like if you are kind of doing slicing and you want to do it using a for loop or something like that, right? Right. Oh, so okay. So let me start with kind of the straightforward thing. So if you say like L2 down to 0 in steps of -1, what this means is L at 2, and then L at 1, and then down to 0, but not including 0. So that's why it's like 7 and then 6. Right. So you can do you can do 0 to 2. It's just that would be empty because you cannot go from 0 to 2 in steps of -1. So this would just be empty. And then this is kind of the valid way of actually doing the thing, which is, start at index 2 and then go to index 1, down to, but not including 0. So if the directions don't match, it's just going to be the empty list. But this is like small details that I would not test you on. Yeah. Yeah.
Are the basics of like popular networks is just like energy and then like item and like is always gonna be the time?
Well, so the triangle, I think you're referring to just having 3 nodes. You could have 4 nodes as well, right? So it could be that the shape is like So that could also happen, right? And in general, in fact, yeah. So in general, in fact, it would be larger. So kind of it's free just to make it manageable. And in fact, like there could be like a diagonal. Well, so the point is we want to have this, so we want to be able to store those numbers, like, the vector x0, x1, x2, x3. And we want to store them using the weights rather than by explicitly encoding numbers. And one thing that you've already seen is that you can have just three weights, but they're giving energies for, 8 different configurations that are possible, right? Because like you just have three weights, W01, W02, W12. But the energy function that we saw in the lab assigns energies to 8 configurations, right? So the weights are like the W01, W02, W13. Yes. Yes. So those guys. Right. So the other thing that it enables you to do is to kind of adjust things a little bit, so adjust the weights a little bit, and that allows you to store new configurations without kind of forgetting the old ones. Yeah.
Can I pop the network energy B square and if yeah, right. You said it was true, but can you actually plot it out if it's a square?
So what do you mean by
Yeah. So what if there's like a 4x's then could you like plot it out?
oh you mean like this one? Oh, like this one?
Yeah, this one's kind of square, sorry. I mean a triangle, but what if we were to add a x3 in that case?
Yeah, I mean like this, right?
Yeah.
Yeah, okay, yeah. Yeah. So is the question.
Can you actually add x3 into that function?
You mean like into this guy?
Like add an x3 so that
Yeah, so I mean, like there would be sorry, I'm not exactly sure what you're asking, but like, are you saying like like if this is the thing, then yeah, like I would have like like see, yeah, so I would have like a term 4, which would be like x0 times x3 times W03, and then I would have a term 5, which would be, I guess, like x1 times x3 times W13 and so on. Is that, sorry, I'm not, is that what you're asking about? Yeah.
For potential energies, what is the second line for x0, like x0 in
Yeah.
that list
So,
mean actually?
so it means make x0 be -1 and then make it be 1, right? So this is like the 4E in L thing.
And it's just you set x0 to be either -1 or 1, but it can't take on other values.
So for this particular exercise, it would be just -1 or 1. There are kind of other models where it can take on, for example, like 0 and 1 or -1, 0 and 1. It does have to be discrete. So it happens that kind of for this kind of set of models, it has to be discrete.
X1 plus x2 and 1.
Yeah, I meant 3. Yeah.
Go over 2023 number 5.
Right, so this is count occurrences. So this is like how many times does this appear in the list? So this is kind of all it is, right? It's like you're going through every element in L and you're saying if they match, then increment it all. There is a typo if that's what you're asking.
Like, is there such as that you cannot use the count method?
Right, which I haven't. Yeah, yeah. So it's just that like what this question is asking is something that you can do just using count. So that it's just that like you could say, return all.com. If it says you cannot use some of the time, it's that there is like an advanced functionality that I specifically want to prohibit, but you might not know about it. Yeah. And if you cannot use it, then you don't need to worry. Like you don't need to use it anyway.
Is return the number of like that specific element appears in that list. Okay. Also another question about another picture. It was like a matrix, and then you want to see if the columns are the same of two matrices. I don't know if it's like which one. It's not
2020, like share and one or something.
But the solution, it did like basically it inverted the matrix so that the columns became the rows, and then
Yeah.
just did it like normally.
Yeah. Transposed. Yeah.
So wouldn't, and then you did the count.
Yeah.
But wouldn't you not, like in this case, you're not supposed to use them?
Never said it. Like unless I said something, unless something was specifically banned, then yeah. Like this was also an online test where we just, like people submitted in grade scope and we just kind of automatically ran it. So like we in fact did then kind of go and look at it as well, but it's hard to ban things when you're like auto grading. Like not impossible, but yeah.
It doesn't matter if it's right. Like, I kind of solved this question with the O value of n to the power of 3. Is that like quite applicable, even though it's not really efficient and stuff?
I mean, so we haven't yet done efficiency, so you're not going to see anything about like it must be this efficient or anything like that.
Or that could create another function with
Yeah.
Code that like creates a list in a folder, like every time the folder runs, it creates another list.
I'm not exactly sure, but what you're asking, but like something like this. So like something like this.
It's like one list.
Okay. Yeah.
You could like pull on and then say create, and then you make 3 lists. Like,
I can see that. Uh, is that the kind of thing? Right.
Like, list 1 is equal to say 0. List 2 is equal to 0. And then like these lists are attributed to their own like the names.
Do you mean like with the dictionary in a dictionary or? I sorry, I can't follow what you want. Like, do you want to like come up and write what you want?
So like, if you have list is equal to like say, one, and then you have lists one is equal to say 0, 1, and like the values don't matter. And then every time you just do like a new list and then just do like list 2 and then list 3 and you just make new lists every time.
But what would they be?
I don't know. This one is
Oh, okay. So what you're asking is you want to create a variable with that name, right? And you're asking like, can I do it in the like? And the answer is yes, but you have to use exact. Because so like if you want to like essentially what you want to say is like you want to do this, but in a loop, right?
Yeah.
So if you want to be able to create like L1000, but you don't want to explicitly say L1000 is equal, it doesn't matter that it's a list, right? It's about like the name of the variables. Then the only way to do it is, well, not the only, but like the way we saw it, how to do it is with exact, where you would say something like, yeah, yeah,
Right?
no, that's right. So
Thank you.
so what you, I mean, like the tuples is really nothing. It's like a list, but you cannot modify the contents. That's just,
Like yesterday, we were looking at like,
oh, I mean, yes, yeah, yeah,
yeah, before we learned it.
yeah. I see. I see. That is usually the situation. Yeah, so sorry. So to answer your question, right? So like it would be like something like this, right? So and then here you could say like print L2 or not fine. Did I? Hmm. Oh, it's kind of weird. Oh, that did not stop there. Not clicking. All right. So now we've defined L0, and now we'll define L1, but L2 is still not defined, right? And now we'll define L2. And now L2 would have been defined. So that is kind of what you're asking, right? Yeah.
and what if we didn't want it to be
I mean, it doesn't I mean, like, oh, sorry, like this is a coincidence, right? It could be a 15 as well.
it to be values from a different like list?
I mean, whatever you want. Like you can put whatever thing here that you want. Like so like let me just put it as like I or something, or like 2 times I. Yeah. So this is like a quite like unusual thing to see. Like this is just like to answer your question. Yeah.
I'm gonna be on this midterm.
I mean, your friend just made it up, so probably not. Like it's using the tools that we did have, right?
So we won't be using it unless we prove them.
Um, no, like that's like nothing to do with it. So like it's just like constructing this line of code and then running it, right?
I just want to confirm that I'm on the right track of the 25 and the bonus one on the 2014 written? Because I'm unaware of that. Like there's actually a built-in function of like a list dot count that actually counts the number of occurrences of each element.
Okay.
Because I'm not sure if we've gone over that, but I have been unaware of that until I see the solution, so I did it differently. Like so, this question asks like the combinations of the four-letter strings.
Okay.
But it has a constraint of like you cannot exceed three like same elements.
Okay.
And I did it quite like complicated than the solution, but I'm not sure if I'm on the right track of like the process. Basically, what this does is like I use another function of like the combination that take a string and prints all the possible arrangement of the four-letter string. But I have a constraint here that like it's kind of quite mechanical, just like you cannot have more than two same like same.
Yeah. Well, so so equals like equals might work as a trinary. I think it should be and though.
Oh, yeah, but yeah, okay, yeah, and if this works, then for the following function here is basically it takes.
Yeah,
I mean, it seems really ugly, but I'm not sure.
Yeah. I mean, the idea was to use exact, right, rather than.
Oh yeah, but if the idea works, then would this?
Yeah. So it was So like I think we allowed it at the time. Like that. It wasn't like the idea wasn't that you would like write it out. The idea was that you would use exact.
Oh, okay. Then if I just happen to nest the loops multiple times, is that like...
I mean, I've learned my lesson, and I wouldn't I would like not allow it anymore.
Oh, okay. Yeah, thank you.
Yeah. Right. Yeah. The only application that we've seen was generating the for loop for all pass rates.
He's writing, so I don't know, like, is it gonna ask, what is this?
So the examples in the previous tests, except for 2010, maybe, where I think some of those might have been in the material so far. The more recent ones, the last question with the prediction output prediction would not be there because we haven't covered the material yet. So in the last several midterms, because they were like a little bit later, they had the output prediction questions that would usually be the last question, and those would not be covered because we haven't covered them yet.
Is that word?
Yeah, I understand. Yeah.
So no.
So no predictions the way there were predictions in the last several midterms. In 2010, I think there are like predictions that could like not like the last question, but just like in the middle, which, like they're like nothing special. It's like the kind of thing that they would ask in a lecture, like what do you think is the output going to be? So like it's like not impossible. Yeah. But like not like nothing like kind of the last several the last question on yeah okay okay yeah okay yeah
That one took us like
yeah and then like she asked like can you quickly go over that and I was like no So yeah, I can try, but yeah, like it might be that like watching the YouTube, like I also woke up at like 4 or something. So like but so let's try. So what we're trying to do here is we're trying to generate this kind of code. So like that's what we're trying to do. Okay. Okay. Does that make sense so far? Like that's the goal. Right. So yeah. So like every possible character 0, every possible character 1, and so on. And then we want to just like generate that. So this would be the thing that we're trying to get. So it looks like this, but if you print it, then it looks like the string. Yeah. So this is every possible combination over the alphabet for 4 characters.
So what if you don't know?
If you don't know, then you would have to do this for length equals 1, and then length equals 2, and then length equals 3, and so on. So it would like if you have a kind of generate O for 1, then you could say like results is initially nothing, and then you extend it with generate everything for 1, and then extend it with generate everything for 2, and generate everything for 3, and so on. So this is like if you had a function which we're about to write, which is like return a list. Yeah.
Does Python know what character 0 is? Like
No, it does. So it doesn't, but this is just a name, right? So this is like if you have like alphabet, and then you can say like for C in alphabet, and C is an arbitrary name, right?
but how does it know what it's looping?
So it's the alphabet. So it's saying like character. So does does the highlighted part make sense?
Yeah.
Yeah. So this is just that, right? Except like this would be like car 0.
Okay.
Right? Okay. Yeah. Yeah. And then this was an answer to your question from before. What if you don't know the length and you want like every possible length? Got my charger. Great. So that's a different one. So yeah. Um I think I'm good. There's just like, oh, we're gonna leave anyways. Thank you. That's correct. That's correct, but we haven't done it. Yeah, unless it's specifically banned. Yeah. No. So that was like the answer to your second question. And then what we needed to do was to generate this string, right? So to generate the string, what you would need is so basically first generate this and then generate this and then this and so on. So this would be I could, I just don't know what S is. Or like if I know how many characters there are, I don't even need exec. I would just write this as code. The point is that I don't know how many nested loops I need. Right? So this would be like space times I plus like this, right? So this is saying like make this line and then make this line and then make this line and then make this line. So I'm just saying like line is this, right? So, this many spaces and then for car and then, initially 0 and then 1 and so on, right? Is that good? N is the number of nested loops. So I is just like, so I'm making this line and then I'm making this line and then I'm making this line. And I'm sticking all of those lines together in result.
We would say for zero in alphabet or for zero.
So what do you mean twice? So like here, like let's say n is 5. So if I print result, it'll look like this, right? That is what I'm trying to